So chapter 4 has 3 sections, right? And when you're going through your book, like it starts talking about, like, it has all those sections about GUI stuff. We're not going to do any GUI stuff in this course. In Java 2, if you take me for Java 2, I do cover that in the second part of Java. So really, there's only like 3 sections from chapter 4 that we have to go over. However, understanding and implementing concepts from chapter 4 can be a little cumbersome. So today, I'm just gonna do a bunch of examples, and then I'm gonna give you a quiz and have you guys write a class on your own. So in the beginning of chapter 1, we talked about the idea of object-oriented programming. So the concept of an object is essentially just an entity of data that kind of manages itself, right? And the purpose behind that is if you want to actually create multiple instances of that data, that object, you can, right? So just kind of like a concept. So suppose I tell you to, I'll just do an example, right? So first example I'm going to do is you have a requirement that says, write a program that prompts a student for his first name, his last name, and 3 test grades, and then compute his test average and print out the results back to the user. Okay, that's a pretty simple program. That's something that we should already know how to do. Use a scanner class, use strings, take the input in, take in the input for the 3 grades, do the math on those 3 grades, like output back the average. Okay, pretty simple program. I'm just gonna type it up really quick. So let me come here. Actually, Notepad++ right there. All right. So I'm gonna create a new file. Dang it, I already had one open. All right, I'm gonna save this as, I'm gonna have to make a new folder called Chapter 4. I call this one grade calculator. And I'm going to save this as a Java source file. Okay, so I'm going to put the requirements up here of what I'm asking for, so that I don't diverge from what I'm asking for. So I'm going to say, just say we got a requirement that says write a program that prompts for a student's first and last name and 3 test grades. Okay, you're going to prompt for the first, the last name, 3 test grades, then calculate the test average and print it out to the console. All right, so I know I'm going to need my scanner object, so I'm going to go ahead and import my scanner class. So I'm going to say java.util.scanner. And then I'm going to go ahead and create my class. So public class grade calculator. Didn't I put on? Oh, there you go. All right. Grade calculator. Create my main method. Public static void main. String array arguments. All right, and I know that I'm going to need a scanner, so I'm going to go ahead and make a scanner that listens to the keyboard. And then for data, I know that I'm going to need the first name, the last name, and 3 test grades. So I'm going to go ahead and create that. So I'm going to make a string for first name, last name, and then we'll say float for test 1, test 2, test 3. Okay, and then I guess the other thing I should do is go ahead and create a constant for the number of test grades. So I'm going to say final int num of test, and we'll just set that equal to 3. And then, one of the other things I want to do is get the test, calculate what the test average is. Okay, all right, so I made variables for the data that I want to store. Now I'm just going to go ahead and prompt the user for this information. So the first thing I'm going to do is say system.out.print. Enter student's first name. All right, and I'm going to go ahead and copy this, paste it again. And this time I'm going to say enter student's last name. All right, and when I get that info, I'm going to go ahead and save it to the first name. Well, first name is going to be equal to scan.next line. And last name, same thing for the last name. All right, so I'm prompting the user for the student's first name and the student's last name. And then what I'm going to do is I'm going to prompt them for the three test grades. Okay, so I'm going to say system.out.println. So I'm going to say enter test 1 grade. He's going to give me a grade. I'm going to change this to print. So the prompt appears, or the entry appears on the same line as the prompt. I'll do that 3 times. So test 1, test 2, test 3. And I'm going to save that data by doing that. All right, and once I have that information, I can just go ahead and calculate the test average. I can say the test average is equal to the sum of the 3 tests okay, and divided by the number of tests. Oh, yeah, you're right. Thank you for that. Because otherwise, I'm just changing test 1 multiple times. Thank you. And then system out print line. I'm just gonna go ahead and print out like all this info. All right. So let me think about this. Okay. So we already talked about the string class. So if you actually go and read up on the string class, there are some static methods that you can call. So if you remember, a static method is a method that can be invoked through the class name. And there's a really useful one. There's also a printf method on the console that you can use as well. So it doesn't matter which one you use. I think maybe in this case I'll use a printf. The book does talk about that one. I don't really like bring it up on exams or anything, but I guess maybe at some point I should probably. But since it's left out of lectures, I don't really go over it. But anyways, the way this works, if you read up about it, you can to me it's really useful. You can make your string and then you can kind of put in like these indicators of where you want to inject data. So I can do something like this. I can say student, well I could say first name, right? And then you do like a %s for a string, okay? And then I'm gonna make a new line and I'm gonna say last name. And then I'm gonna do a %s for a string, meaning I'm going to insert a string at that location. And then I'll say like test 1. And then for a float, I believe it's %f, then new line. I'm just gonna copy this instead of having to type it over and over again. Dang it, sorry. Hit the wrong key. All right, and then I'm gonna do test 1, test 2, test 3. That's test 2, test 3. And I guess the test average, now I'm kind of running out of room here, So I'm going to divide it like right there. And I'm going to say test average. All right. So the way this method works, the printf is you're going to insert data, or you're going to make a string to where you kind of give it like an indication of what type of data you're going to insert, and then where you go ahead and write that string out, and then you're going to add in additional parameters. Like, so I'm going to do like a comma here, and then I'm going to just go ahead and add in additional parameters of information. So the first thing I'm going to print out is the first name, then the last name. I'm going to go and put this all on a different line. First name, last name, test 1, test 2, test 3, and then test average. Okay, so what's happening here is these are the parameters that I'm telling this method to inject at those locations. So the first parameter needs to be a string, and it's going to go right there. The next parameter needs to be a string. It's going to go at that %s. Next one needs to be a floating point number. It's going to go right there at that %f. I think it's %f. I always get these confused, but I know %d is integer. I believe %f or d is for floating point. And then like the 3%fs are my test 1, 2, and 3, and then the last one is for the test average. Okay, let me go and just compile and run this to make sure it works. So there's information about this method, printf. The book does talk about it. If you want to know more about it, you can look at the API for Java. It does tell you like different ways to like format and layout values. Okay, so let me just hop over to command prompt. Change directory to Dropbox, public, public MVC, Java shared content, demos, chapter 4. All right, and I'm gonna go and compile. And I think there's only one class in here. Yes, one class. Okay, compiled. That's good. And then I'm gonna go ahead and run this. All right, student's first name, I'm just gonna say, I'll use my own name. And then for test 1, 45, then I got a 98, and then we'll say a 87. Okay, so then it says the student's first name is this, last name is that. Then there's his test 1 grade, his test 2 grade, his test 3 grade, and there's his test average. Okay, so I did all that just by formatting that. I don't know, to me it's easier to, like when I want to lay out data in a particular order, it's easier for me to use a formatting method to do that. Instead of just concatenating in a bunch of stuff. Like you can do, I'm not gonna grade you on that. So if you wanna go and concatenate everything in, you can. I'm gonna go ahead and do a new line right there. And I noticed I misspelled first name. Okay, so that is how that's how you would print out or ask for a student's first and last name and then print out that data. Okay, and you can also like format these if you want. You don't actually have to use the number format or the decimal format. The cool thing about this formatting method is if you want to actually put it to 2 decimal places, I believe all you have to do is do like a, for anything that's floating point, you can do like a point, how many decimals you want after the decimal point, like 2, I believe. I don't know. Let's see if it works. If it doesn't, I'm gonna have to like read the API on this really quick. Save that and come over here, compile, clear my screen, and run. All right, and I'm going to enter somewhat, so what did I say, 67, 98, and I don't know, I forgot, 87. All right, and it did do that. However, wait, that's not right. It did, made it 84. Oh, so that is the average of the two? Okay. I had 45, dang. I think I would have done better than a 45. I'm typing too fast. All right, so I said 45, and then I said 98, and then 67. Dang it, still doesn't work. Okay, so I have these wrong. So maybe it's just like the decimal format. You put like how many spots you want, or say 2 like that. I don't know. I think I'm gonna have to just read up on this really quick to get this working correctly. Yeah. All right, let me save that. Oh, I got rid of it. Thank you. All right, let me clear the screen. Compile. Run. And then 45, 98, 87. Dang it. I messed that up. All right, so since I don't know what I'm doing, I'm going to have to look it up. This is what you guys should do when you don't know how to do something. So I'm going to say Java 8 API. I'm going to say format. We'll go to string format. It's the same. It should be the same thing as. Click here. And let's see what it says about decimal points. I'm just going to kind of just scroll through until I see what I'm looking for. But it doesn't tell me anything. It's just, I think I have to go down to the formatter method. Let's see. So string. Oh, this is a, okay, this is a string class that I'm in. I want the, okay, let me look at the format method. Format and okay, hold on. Let me just do this. Java format string. I'm gonna click on this real quick. And so F is floating point decimal number. What does D say? Oh, D is for an integer. Okay, I said D. I think, okay, D is an integer for some reason. And F is for floating point. Now, what if I want to get just fractions of the number? All right, didn't see what I was looking for. So now I'm just going to say Java print F floating point precision. There you go. Okay. It did, yeah, but I want to see if I can get something from Oracle that gives me more explanation than exactly what I'm looking for. Oh, it's here. It says 0.2f. What the heck? So system out print line. Oh, like if you want, okay, so if you want to put like, if it's money, you can put like a $sign and then like, if you want commas in it, .f. I must have did something wrong when I did mine. Okay, it is, I thought it was a decimal. I don't know. Okay, so let me just do this again. Let's try one more time. If it doesn't work, I'm going to pretend like it did work and then move on. All right, saved it, compiled, clear, run. All right, so 45, 98, 87. Okay, so I must have did something wrong when I entered in the first time, right? Because then they come. Yeah. All right. So it is the 0.2. Like it kind of threw me off and went down a unintended rabbit hole. But anyways, so you can use these to format the decimals as well. Like if you didn't want all those trailing zeros, right? Because floats will show 7 significant digits. So if you just want to trim it down to where you don't really care about anything past the hundreds place, you just do a 0.2 and then it will do that. Any questions on that? All right, so I wasn't really trying to show you how to format strings. What I was really trying to show you is the benefit of using or like using classes and creating objects. Okay, so now I'll just tell you. I'll just say, you know what? I want to write a program that to write a program that prompts for students' information. Blah 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 blah. But I say do this for like 3 students. Okay. Now you're gonna have to come over here and just basically copy all that data, 3 times, and then change this one like test 1 for student 2, test 2 for student 3, right? Like, and so on, right? So you basically just multiply the amount of information that you have to manage as you increase the number of students that you want to track this for. What if I said, you know what, write this program and it's going to retain data for all 20 students in this class, right? Am I going to like create variables for every single person, right? Everybody's going to have to, like, if I'm using this approach where I just have one class to handle all this, it's going to get overwhelming as I continue to add more and more students. So that's why like writing your own class has its benefits from managing the data. And then once I have that class, I'll be able just to instantiate an object of that class and then use it repeatedly to meet the requirement for these 3 students. So now what I'm going to do is I'm going to, let me see, what should I do? I'm just going to keep this the same, right? I'm going to remove this requirement out of here. And I'm going to save this as something different. We'll call this one grade calculator 2. But the grade calculator 2 is going to actually depend on a student class. So I'm going to rewrite this. I'm just going to leave this alone for now. So now what I'm going to do is I'm going to make a class for the student. And it's going to essentially just be a class that is a blueprint for an object. And that object is going to have a first name, a last name, and 3 test grades. Okay? So I'm going to come over here. I'm going to say new. I'm going to say file, save as. I'm going to call this one student. And what I'm going to do is I'm going to save this as a Java source file. Save. And I'm going to say public class and then student, open close parentheses. Now there's no main method in here because this class is just for being a blueprint of an object. So data that I'm going to want inside of this object, and I'll make them all private. We'll talk about access modifiers in the lecture. But an access modifier basically just restricts who can see this information. When we mark something as private, we're basically saying only the class can see that information. So you have to be within the class to see this information. So when I say class, you have to be inside of the student class in order to see whatever I'm going to put here. So I'm going to say private string, and I'll say first name and last name. Okay, and then I'm going to make a private for my test grades. So I'm going to say test 1, test 2, test 3. Okay, and I guess another thing I can do, just is make a constant inside of here. Since it's a constant, I can make it public. I'll say public final int num of test. Okay, and I'm going to set this equal to 3. Now we can make a constructor. So a constructor is essentially an object that is used to set up is a method used to set up an object. We'll talk more about that, but for now I'm just going to kind of ignore the constructor just because I think it just might make things just a little too complicated for now. Okay, so now what I'm going to do is I have this data that I want to manage. So I'm going to make what we call getters and setters for this data. So I do that by following the pattern of a setter. So I'm going to say public void. A void type is something that whenever you say something is void, a method is void, it just means that no data is going to return from that method. So I'm saying public void set first name, and I'm going to take in a string, and we'll just say the string that I'm going to take in is going to be some value. Okay, open close curly braces. So I'm defining data that I want to manage, now making methods that are going to be used to manage that data. So set first name is going to take in some value, and it's going to set the first name of this object to whatever value that is being passed in, right? I'm basically just telling Java, I want to make a public method that can be used to change the first name of my object. I want to also do this for my last name. I'm going to take in a string, and I'm going to set my last name equal to whatever last name was passed in. Okay, and then I want to do the same thing for test1. So it's going to be void. I'm going to say set test1, but test1 is a float, so I'm going to take in a float as the value. And I'm going to say, okay, well now test1 is going to be equal to whatever value that's passed in. I'm going to do this for test2 and test3. Okay, so I'm basically writing a class that is going to manage the first name, last name, and the 3 test grades. Okay, now setting them is okay, but how am I going to expect whoever creates a student object to actually see what the information is? And then if you want to provide the service of them being able to see the data, then we're going to make what we call the getters, right? So we have our setters, which set the data, and then we have our getters, which gets the data. So you can kind of think about a object as this entity that holds data inside of it, and all that data we declared the data to be private, meaning that data can only be accessed within inside of this entity. Okay, now we're providing public services. These services is what we use to tell our object to do something. Set the first name, get the first name. Set the last name, get the last name. Right? We're pretty simple, right? Pretty simple things. We're setting and getting data. So I'm going to go ahead and create these getters. So I'm going to say public string. So now that I'm going to return data, I'm going to specify a return type. So public string get first name. And I'm going to say return whatever values in first name. And I'm going to do that for my last name and my 3 test grades. Okay, so I'm returning the string, and I'm saying get last name, and that's exactly what we're returning. Oops, I forgot my semicolon. I forgot it up here as well. All right, and then I'm also going to have to make a getter for my test grades. So it returns a float. I'm going to say get test 1 and return test 1. Okay, so I basically just provided additional services, right? Also retrieving the information. Now, I'm going to draw this up because normally I would go up to the board and draw this, but I'll try to do it here. I found out I have this really cool whiteboard thing on my laptop. Okay, so this is kind of the concept of this object, right? So I'm defining a class, and whenever I instantiate an object of this class, I'm basically having this entity here that is going to have data for the first. Dang it, I can't write on this thing. What the heck? All right, hold on. It's going to look really bad. I'm sorry. Okay, that's the first name. That's the last name. And then here's test 1. This went much better in my head when I thought about using this. Okay, so that's the data that I have inside of this student object, right? Now, the only way that you can change that data is through public services, and those services I'm providing are set first name, right? Set last name, and then I also have the 3 test grades, right? Set, we'll just say like T1, set T2, set T3, okay? So I have those services that I provided. If you look at my class that I defined, those are the first methods that I actually created, right? So here's my data, and I provided these services to actually pass in data so that we're able to actually set that data. And now the other services that I also provided was services to get. Like these are all my getters right here. Okay, so this is get. I'm just gonna put get on it. Okay, so like get first name, get last name, get test 1, get test 2, get test 3. Okay, so then I have my driver over here, which is my grade calculator, right? So my grade calculator is over here. Here's my program right here. We'll call this one grade. Actually, that should be a capital G, right? Grade cal. And it's going to instantiate an object here. Say instantiate. It's going to create this entire object, right? This entire object's going to get created, and then this object is going to have a reference to the object like right here. And then whenever it wants to set the first name, it's going to basically tell that object, okay, go ahead and set the first name. Whenever it wants to get the first name, it's going to request the data, right, through the method get first name, and it's going to use the first name wherever it needs to use it, and to say that call is like right here. Okay, so this grade calculator is essentially going to make this object, right? Tell Java, go ahead and instantiate this object, and it's going to pass in the data that it wants to keep into that object. And then when it wants to get the data from the object, it's going to request it through the getters. Now there is another method that we have to create, and the other method that we're going to have to make is a way to get the test average. Okay, so I'm going to make a method called like let's see, not get. We'll just say test average, calculate test average. I don't know, something like that. We'll say cal test average. Now the reason I'm not going to, I hate calling it. Oh, yeah, okay. Anyway, so the reason I don't want to call it get test average is because calling it get test average is giving you the false assumption that it's actually a getter method. Whenever you have a setter and a getter, people automatically assume that there is what they call instance data for those methods, meaning that they were defined up here. The reason why I do not want to define test average up here is because it should be something that is calculated as like on-demand basis. Meaning if I had a variable up here called test average is dependent on the value of test 1, the value of test 2, the value of test 3. If any of those values ever change, that means your test average, just whatever you have for your test average, just went bad, right? So you're going to have to, if you change test 1, you're going to have to recalculate test average, right? If you change test 2, recalculate what test average is. However, if you just make the test average a service, then as it's needed, you will just do the calculation and then return back that value. So I want to make a public float cal. I'm just going to call it test average. Test average. Okay, and then in here, like in the main method, whenever you want to calculate something, you can just maybe create a float for sum of tests. The sum of tests is going to be test 1 plus test 2 plus test 3. Okay, and then I'm going to just say float average. The average is going to be sum of tests divided by num of tests, right? It's basically whatever I summed up top and then divided by whatever the number of tests that I have. And then I'm going to return my average. All right. So every time they invoke the method test average, these two statements are going to kick off, and it's going to give me a brand new test average through that method. All right. So now that I have all this class defined, I can hop back over to grade calculator 2. Now, grade calculator 2 is simply just grade calculator 1, but instead of me managing all this data inside of this grade calculator, I'm going to just simply create a student object, and I'm going to go ahead and just set the data as I'm getting it from the user. So I'm going to come over here. I'm going to rename this to grade calculator 2. I don't need any of this data anymore. I can just go ahead and get rid of it. Okay. And now what I'm going to do is I'm going to go ahead and just make a student object. I'm going to say student. We'll just say stud1 is equal to new student open close parentheses. Now, I didn't actually define a constructor in my class. We'll talk about constructors some more in a bit, but I just kind of wanted to introduce getters and setters and then like this additional method down here before I get into constructors. So I basically instantiated a student object at that point, okay? So what Java's gonna do, it's gonna say, okay, I'm gonna have to put a new student into memory. It's gonna come over here and look at all this data, and it's gonna make room for a student object in memory. Now that data exists in memory, but nothing is currently set, right? So Java went ahead and put that object into memory, but that data actually has no valid values. So if I were to like run a get on all the information, you'll see that all the data is like blank, okay? So just as a proof, let me just go ahead and delete all my outputs right here. I'll just go ahead and Control X that, and let's just see what is stored in my object currently. So if I say system out print line, and I'll just say first name, first name is, and then I'll get my student object. And just like we were able to do for a string object, I can now invoke methods through my object. The methods that I can invoke are the methods that I created over here. Okay, so the first thing I want to try to do is get my first name. It is a method, so you have to do open close parentheses, and we'll see what value is stored there. So I'm gonna go ahead and save this. I'll hop over here, clear my screen. I will compile. Okay, it did compile, which seems cool, right? I mean, I just did a bunch of stuff. And I want to run grade calculator 2, and you can see the first name is null. So does anybody know what null means? Ted? Right. So it means technically it means nothing, but what it really truly means in Java, we have what we call object reference variables. So this student stud1 is what we call an object reference variable. It's pointing to a location in memory where the student object exists. Okay. Now, Java came over here and said, okay, well, I need data for all these parameters here. A string is what we call an object. So first name is an object reference variable that is going to point to some memory location of where that string object exists. However, I never actually created a string for my first name to point to. So null just basically means it points to nothing, right? It's like uninitialized, right? So that first name of that student doesn't point to any place into memory. It's there's no data there, right? It hasn't been set. If I were to print out my test 1 grade, I'm gonna get back a 0. Now for primitive data types, it actually is gonna give you some type of value. Java will just set that value to 0, but we did not actually initialize it anywhere. So I'll just say like test 1 grade is, and then I'll say student1 dot get test 1. Let me go ahead and save that. Hop back over here, compile, run. As you can see, that test 1 grade is 0.0. Okay, so like none of this data is actually set. All right. Now, just for debugging purposes, it's always a good idea to write a toString method. Now, a toString method is essentially a method that is going to give me a string representation of my object. Now, every class that we create automatically inherits from a class called object in Java. So there's already a toString method created for you, but we want to override that and print our own toString method. All right, this is what the toString method looks like. The toString method gets invoked whenever you print your object to a string or the console. So right here in the system.println line, what I'm going to do is just say, okay, we'll just print out stud1. I'm just curious to see what the toString object is, or toString method does for stud1. When I come over here to compile and run, you can see that my toString says student and then at and then some hex value. Okay, so the hex value corresponds to its location in memory. So it's basically telling me there's a student object right here, like that's where it's pointing to, that object reference variable. Now, if I wanted to change that to be something meaningful, I would hop back over here to my student class, and I would make a toString method that returns data for the student object so that I can debug, I can know what the current state of my object is. So the way you override the toString is you just say public string, and then you say toString, open close parentheses, and then you just return a string right here. Okay, it could be any string, but it should be something meaningful. But if you wanted it to be something not meaningful, you can just type whatever here. You could just say like tacos. You can save that, and then when you come over here to compile and run, you can see that that's now what you get whenever you print that student object to the console. Okay, so whenever I print out this object reference variable, it's pointing to the object in memory. This method is now getting invoked. It's just printing out tacos, which makes no sense for my student object. So I should probably change this to be something meaningful. This is where I like to use the string.format method. I could say string.format, and then I have some type of format that I want. I want to know the name of the class, which is student. And then the other things that I want to know is, okay, well, I want to know all the instance data. I want to know my first name, which is a string, so I do %s. I want to know the last name. I'll do a %s. I want to know test1, and that is going to be a %f. And test2, that's going to be a %f. And test3, which is going to be a %f. All right, and this works just like the printf method, where you call the string format, and then you just pass in the variables that you're going to format, okay? Or you're going to inject into those locations. So I have a string, a float, and a float. So I'm going to put the first name, last name, test1, test2, test3. Okay, I'm going to save that. And now when I come over here to compile, I'm going to clear my screen. I messed up somewhere when I compiled. Let me see, string format, have my string. I didn't see what I did wrong. I forgot misspelled string. Is that what you're, okay. Yeah. I'm going to spell it correctly. I'm going to hop back over here, compile. It compiles. And now I'm going to clear my screen, and then I'll run. Okay, and then here is my toString that I just created. So it's right there I can see, okay, well, first name's null, last name is null, test1 is 0, test2 is 0, test3 is 0. All right, so I can see my object. I instantiated it, but there's no data that has been set in my object. Okay, so I'm going to go ahead and slap back in everything that I took out. So I'm going to, hold on, let me Control Z this. All right, there's everything that I took out. All right, I'm going to keep all the prompts the same that I did the last time, except I don't have no first name anymore here, right? The first name exists on my student object. So if I wanted to set the first name of my student, I'm going to have to say stud1 dot set first name, and then I'll pass it into there. And just for good measure, I want to do some debugging as I'm asking for all this information. I want to verify that it's actually being set. So I'd say, okay, well, just print out whatever stud1 is. Okay, I'm going to do this for first name, for last name, for test1, test2, test3. Okay, I'm gonna have to go, this is no longer valid because last name doesn't exist inside of this main method. I'm gonna actually pass this string into my object, which is stud1 dot set last name. Okay, and then for the test1, same thing. It goes into stud1 dot set test1. All right, and for this one right here, actually, let's copy this whole thing. Like, paste it there, and I'll just change this from test1 to test2 to test3. And then my test average, I don't need to do that anymore. I can just delete that here. And here I was having some really nice printout. I'm gonna go and just get rid of all this. And I'll just, I print everything out right here. And then the last thing I'll just do is I'll say system out print line. Test average is, and then I'll print out the test average by saying stud1 dot test average. Okay, save that, and every time I prompt for data, I'm basically just printing out the object so I can see it updating as I ask for more and more information. So I'm gonna come over here, I'm gonna compile. It compiles, good. Clear my screen, run my program. I'll just say Mike. That's not Mike, but close enough. All right, you can see that the first name got updated. Okay, last name. You can see that the last name got updated, right? First name's still there as well. Test one, we'll say 45, I think, right? All right, you can see that the test one got updated. Now I'm going to enter in my next grade, 98 and 87. And now you can see that all the data got updated, right? So there's that student object with all its data updated. Okay, and then there is the average, my test average. I just invoked the method test average. And the reason why it's always good practice to not create instance data variables for things that are calculated off other ones is because I have the option of coming over here and saying, okay, well, let me just take my test one grade. I'll say set test one grade to a 0. Okay, and now that I set it to 0 after this program is done running, right? If I had stored my test average as an actual variable, then my test average would be wrong at that point. However, because I calculate my test average on demand, when I recalculate my test average after I set the test grade to 0, you'll see that the actual test average will change according to what was changed for test one. Because this method simply just, as soon as you call it, it gets the sum of all tests and then divides them by 3. Right, pretty straightforward. Okay, so I'm going to go ahead and compile and run this one more time. Say 45, 98, 87. Okay, and here's the point to where my test average was 76.6666664, right? But then I went ahead and updated my test grade to 0, test one grade to 0 right there. You can see the change actually took place because right there was 45, 45, 45. And then you can see that my test average is now 61. Right, makes sense, right? So like now, if I said, okay, well, make a program that does this for 3 students, it's still going to be cumbersome because you are going to have to like instantiate another object, remake all these prompts, right? And do this for the student. But there's ways to make this more efficient. Like if I use an array of students, you set that array to be 20, and then as you iterate through a loop, I'll ask those prompts, and then you can just enter in all the data. And when you're done entering all the data, I can just print out all these students, and you can see all their names and their averages, things like that. But because I moved the data away from my driver, I now call it this separation where I have my interface for the user, and then I have like the actual data that I'm managing somewhere else. I'm not merging the two, which is like actually like a really bad idea. And the reason why you don't want to do that, I guess I should probably draw this up. We'll see how it comes out though. Let me see, can I make a new one? Yes, all right. So because I created a class to manage my data, right? So you can kind of look at this as, this portion right here as the interface to the user. I misspelled the interface like right off the bat. Okay, so there's the interface, and then, but this interface is not managing the data anymore. The data is being managed over here, right? Here's my data. Here's my student data. Now the benefit of this is you're disconnecting these two, right? There's like a disconnect right here. Now we're doing everything in command prompt on this interface, but just say your skills improved, you went ahead and read all the GUI stuff all by yourself. Now you can make a GUI right here, right, and still use the stuff for student data. You just change the way you ask for it. Right? You like everything's managed over here for the student, right? But the interface is something different now. Right? So having that disconnect allows you to just do your data management somewhere else, right? And now that class can be reused on a different program that uses like a GUI interface or just does something different. Okay, so that's the benefit of separating everything. If you dumped everything into one file, right, it's going to be really complicated to extract all that, lines of code that are the data management and the lines of code that are the interface to the user. But if you immediately just separated the two, then you can have your student object living over here, right there, right? And you can decide whether you want to make a program that uses an interface or a program that uses a GUI, okay? But you don't have, because you've already created this class, you don't really have to worry about the implementation of how the student management is done. Does that make sense? All right, so let me do another example. I know that was a lot to absorb, but you're gonna actually have to do this on your midterm. So just keep that in mind as the next 2 weeks progress. This is what we call object-oriented programming, where we separate out the data that represents the concept of an object from our actual program. Okay, so the next thing that I want to demo is something that the book actually talks about, is having a die, the concept of a die. Okay, so let's actually think about, let me make another picture really quick. Sorry, I'm starting to like making pictures. So let's think about the concept of a die, meaning like die is singular for dice. Okay, so here is a die, like a square, right? And then you have like one dot here, maybe like two here, three here, and then like each side has a certain amount of dots. Okay, now the concept of a die, if you think about it, like what services does this die actually provide when you use it? Anybody know? Wait, what? Right. I mean, well, the most important thing is you can pick this up, and then you can roll, right? And you'll get like, if you roll it, you'll just get like a random number, right, between 1 and 6. Okay, that's one use of a die. What other things can you do with a die? You can set the face value, right? Like, so if you set the face value, what does that mean? That means like you actually you pick it up. You pick this die up, and then you just place it so that there's 6 dots facing up, right? Like that's just me getting the die, just setting it on the side that I want facing up, right? Everybody agree with that? The other service that it provides that you probably don't really think about is you get the face value, right? So how do you get the face value? You just look at the die and determine which side is facing up, right? So it's something visual that we do, right? We just kind of like, we'll look at it, right? And then by our look, we're getting the face value, right? We're seeing that there's 2 there. We roll it, and then we get the face value. We see there's a 3 now or a 6 now or whatever, right? So it's a pretty simple, like the concept of a die is really simple. And the idea of actually writing a class for a die is straightforward. I mean, what data does a die contain? Just the face value, which can be 1 through 6, right? So it has a face value. It doesn't really have much else, right? You have a getter and a setter. Your getter is to get the face value, right? That's us looking at what value we see on the die. And you also have a setter, which is to set the face value, meaning that's us just picking up the die and setting it. And then we have an additional method where we can pick up the die and just throw it and roll the die, and it's randomly going to produce a face value between 1 and 6. Okay, so that's actually a pretty simple concept. I'm going to go ahead and just create a class for that really quick. The book also does the exact same example. So I'm going to make a new class, and I'm going to save this as, it's going to be in chapter 4. I'm gonna call this one die, and there you go. Okay, so same concept. We have public class die. There's not going to be any main method in here. The only thing in this class, because it's designed specifically for managing data, right, and to create objects of die, is going to be like our instance data and maybe some constants and our methods. So I'm going to have instance data for the face value. So I'm going to say private int, and I'll just call this one face value. All right, pretty straightforward. I'm also going to have a public final int called number of sides, I guess. Yeah, num of sides. Because in some cases there can be like 8-sided die, I guess, right? Or multiple sided die, but this one is going to have 6 sides. Okay? And I'm going to go ahead and create a constructor. We hadn't talked about this yet, but my constructor is going to match the name of my class, which matches the name of my file. So my constructor is this right here, okay? So a constructor is an object that initially sets up your die, or excuse me, I keep saying object. A constructor is a method that it was going to initially set up our die. So what do you think we want to do to our die when we first create it? Anybody know? Like when you first instantiate a die and put it into memory, what do you think we should do? Set its value, right? We can either set it to something that makes sense. So what value makes sense? 1 or 6, right? 1 through 6. I shouldn't, because if you don't set it, it's just going to be 0. And then you have a die like when you first create the object, you're going to have a die in a state of having a 0 face value, which makes absolutely no sense. So I'm going to, as soon as you instantiate this object, I'm going to say, you know what? Well, let's go ahead and default the value to 1. That's something that makes sense, okay? You can roll it if you want, I guess, randomly set it. I don't know, up to you. I see people do it different ways, but we at least want to have a value that makes sense. All right, good. Okay, so we're gonna make my getter. So public int get face value. And that's simply just gonna return whatever the value of my die currently is. Okay, it's just gonna return face value. The other thing that I wanna do is I want to have a setter. So public void set face value. Okay, so set face value. What that's going to do is take in some value that is being passed in, and I'm going to just take that value and blindly set it to whatever is passed in. Okay, does anybody see a problem with this method though? Like, what are some of the drawbacks of the way I just wrote my setter? I mean, value is the value that is being passed in. I'm sorry, what's that? What do you mean by specific? Like, no, I mean, I think you might be going down the right track. Exactly. That's exactly what's wrong with my set face value. So, I don't know if you guys heard what she said. Any value can be passed in here, and that's completely true. You can give me a negative 2 billion because that's the lower end of a integer, and I'm going to take that value and just blindly set it to my face value. And that doesn't make sense. I mean, if you look at our die, I mean, how difficult would it be to put 2 billion dots as my face value, right? I wouldn't want to do that. Doesn't make sense, right? My only possible values are 1 through 6. So we don't really know about if statements or if conditions yet, but I'm going to go ahead and use one just because it's something we're going to cover in 3 or 4 weeks. So you might as well just start getting used to seeing them. So what I want to do, the correct thing to do here is limit what the value you take in is, right? So what we can do is if value is greater than or equal to 1 and value is less than or equal to our number of sides, then I'm going to go ahead and take in that face value. Okay, so basically what I'm saying is only set face value if value passed in is 1 through 6. Okay? So if I didn't have that here, this check here, they can pass in a negative 99. It would be taken in and set as my face value. They can pass in a positive 1,000. That would be taken in and set as my face value. But because I have this check here, I'm preventing my data from becoming invalid or corrupted. So that's another benefit of using a class to manage your data, is you provide public methods that you can do a value check on, or some type of data integrity check on, to verify they're within the specific range or specific value of what you're expecting. For a face value, for a die, I expect 1 through 6. If I didn't have this check, it could have been anything. Okay, so the last thing we're going to do is we're going to make a roll method, which is just going to set the face value to a random number between 1 and 6. So I'm going to say public void roll. Okay, so what I'm going to do, my roll method, is I'm going to create a random number between 1 and 6. I can use my math.random, which I'm really comfortable with using, or I can use the random class. Because we just talked about chapter 3, I'm going to go ahead and just stick with using the random class. I'm going to say java.util.random. Okay, so every time you roll, I'm going to just instantiate a random object. Okay, and then what I'm going to do is I'm going to set face value equal to rand.next int, and I'm going to pass in a 6 here. By passing a 6, what are my values? What's that? 0 through 5, right? Passing in a 6 gives me 0 through 5, so I want to change that by 1. So I'm going to go ahead and change that by 1 there. And that means my face value will be 1 through 6, right? I just got the range of 1 through 6. Okay, the other thing I want to do is just make it 2-string so I can kind of observe what the state of my object is. I'm going to say public string to string. And I'm going to return a string that represents my object in some way. And I want to say die, and then I'll use square brackets here, I guess. Face value, and my face value is an integer, so it's %d, and then I'll just pass in face value. Right, real simple. That's my 2-string method. Is I basically just returning out that string. All right, so let's go ahead and use this. So I'm going to go ahead and create a new file. I'm going to save this one as dice game. We'll say dice game 1 because I plan to make more as we go through chapter 4. And I'm going to save this as a Java file. Now this is the class that's going to have my main method. So say public class dice game 1 open close parentheses or or curly braces, and then public static void main string array open close curly braces, and I'm going to go ahead and instantiate my die. I'll say die is new die. Okay, and then right off the bat I'm going to just do a system.out.println, and then I'm going to print out my die object. I'm just curious to see what it is, so I'm going to come over here and clear the screen. Oops, clear the screen. Java C, dice game, yeah. Then Java dice. All right, and then I just instantiated die, and it's just 1. Okay, I'm gonna come back over here, and I'm gonna have 2 dice. I mean, most people play dice games with 2. I'm gonna have die 1 and die 2, and I'm just gonna print out what they are here. So I'll have die 1 and die 2. Those are my face values. Compile, run. As you can see, I have 2 die objects, and both are currently set to the face value of 1. Now I'm going to try to set their face value. I'm gonna set die 1 face value to negative 9999, and I'm gonna set die 2 face value to 3. So the first one is in the range, the second one isn't. And just to prove that my getters actually work, here I'm gonna say die 1 face value is, and then concatenate in get face value, open close parentheses, and I should probably just copy this, paste it, and then change this to die 2 and get die 2's face value. Save that, hop over here. Oh, thank you for paying attention. All right, so I'm gonna hop over here, compile, run, and then you can see that when I try to set it to negative 99, it didn't actually work. It just ignored that invalid value because I have those if conditions set up. And for dice 3 or for dice 2, I was able to set it at the 3. Now, if I didn't have that check on my setter, just say I came over here and for some reason I said, you know what, I hate if statements, they suck. I'm gonna go ahead and just comment it out. Now, when I save this and come over here to compile and run, you'll see that the face value negative 999 actually took effect to my die. Okay, so that's why it's important to have setters that actually limit your data, right? You're preventing your data from being something that doesn't make sense. So that's why I use the if statement to prevent that from happening. Now, the other thing that we didn't test was the roll. So we can roll our dice. So let me just, I'm just gonna make a for loop. We'll roll it a few times. I'll say for int x is equal to 0 while x is less than. We'll roll this 10 times, and then we'll say x plus plus, and then I'll just say system.out.println. I'll print out what the roll is, or what roll count we're on. Okay, actually I'll do x plus 1 because we're going to start off at 0, so it's really like roll 1, but it's going to say 0 up here. It might be confusing to some people. All right, so there's my roll, and then I'll just say system. Actually, I'll just copy what I did here. Print out die 1, die 2, and then maybe I want to get the sum to see what I rolled when they're added together, and then I'll just take die 1 and die 2. Wait, what do I have? 2 of those right there. All right, I'll take die 1 and die 2, and I'll just sum them up together, but I'm going to wrap it in parentheses so that the math occurs before the concatenation, because there's a string here, right? So I'm basically just summing them up right there, taking the face value of die 1 plus the face value of die 2 and just printing out what the sum is. Okay, so before I do any of this, I'm going to have to say die 1 dot roll and die 2 dot roll. Okay, so I enter this for loop. I'm going to roll die 1, die 2, and then I'm just going to print out what I got. Print out the face value die 1, print out the face value die 2, and the sum of the 2 dice. I'm going to do like a blank system out print line right here, just for like separation in the prompts. Okay, I'm going to save that and hop over here, clear my screen, compile, run, and I ran it 10 times. So if I scroll up, you can see this is where I first started off, where I instantiated my 2 objects. I just printed out what they were, face value 1. This is where I try to make die 1 face value negative 999. It didn't take. Here is where I try to make die 2 face value 3. It did take, right? That was me just setting the value. Then I rolled my dice, and I got a 6 and a 1. The sum was 7. I rolled it again, 5 and 2, 7. Third time, 1 and 1, I got a 2, and then a 5, 9, and so on and so on. You can see that my numbers never really go outside of the range of 1 and 6 because I use the proper range for my random number generation. And I got some 10, some 5, some 7, 9, 9. Okay, any questions on that? All right. So like I said, I was going to give you guys something to do. So I know a lot of this is like, whoa, this is freaking crazy. I have no idea what he's talking about. Unfortunately, like I said, this class does move pretty quick. This is the most important chapter in our book. So we are going to be doing lots and lots of quizzes in chapter 4. So expect at least 2 a day. We come in, we do one. I'll lecture, you do another one. I'll send you home with one. I'll surprise you at your house with another one. Yeah, I'll just keep giving to you over and over and over again until all this kind of just sets in, right? So the concept of all this is you're separating out the interface from the data, right? But whenever it comes to like identifying what you actually want to create your class to be, you have to kind of sit down and think about, okay, well, what do I really need, okay? Now, our die, like I kind of just wrote up a quick example, but there's other properties of a die that we didn't need, right? Like the color of the die, right? Some die are white, some die are red with white dots, right? If I were doing a game where you actually see the dice roll, then those are probably properties that I'm going to want to put in my die class, right? But because for this specific program, I didn't need any of that. It's just all through the console. All I needed was just a way to randomly generate a number and then print that out, right? Just a roll and, a get and a set. Pretty straightforward, okay? So what I'm going to have you do, it's almost identical, is a coin. Make a coin, okay? But the idea behind the coin, let me just draw this up really quick. Let's see. So come over here, new. Wait, that didn't work. Okay. All right, so let's think about a coin. So the idea of a coin, it can have a value, a numeric value and all that, but we're not going to make that type of coin. We're going to make a generic coin that is just going to be used to flip, right? So here's your coin, and then you have your heads right here. I'm just going to say H. And on this side, you have your tails, T, okay? So the properties of this is identical. You just have a face value, okay? You have a face value, and what's your face value going to be? Heads or tails? I know that seems really complicated because they're strings, so let's not overcomplicate this. We'll just say the face value can be 0 through 1, where 0 is heads and 1 is tails, okay? So you don't have to you don't have to print out heads or tails. If you feel like you want to actually show heads or tails, you can, but treat face value as a number, an integer, and it can only be 0 or 1, okay? All right, and then services that this coin is going to provide is you're going to be able to look at it, right? Those are your eyes, your beady eyes, and you're going to be able to get the face value, right? Get face value, okay? And the other thing you're going to be able to do is you're going to be able to grab this coin. You're going to be able to pick it up and place it on whatever side you want, right? So this is going to be, that's you picking it up, and you're going to set face value, right? So that's your getter, that's your setter, and you can set it to either heads or tails, but you shouldn't be able to set it to, anything besides heads or tails. Unfortunately, because we don't know anything about if statements, you don't have to do the requirement of limiting it between 0 and 1 on the setter. But if you are so brave to actually try to attempt to make an if statement, I'm not going to stop you, but don't worry about doing that part. Just, you're going to have to assume that whoever's setting the face value knows that they can't set it anything other than a 0 or 1. And then the last thing you'll be able to do is just pick up this coin right here and flip it. If you flip it, then you're going to get a random value between 0 and 1. Pretty simple, right? 0 and 1. Right, what do you pass into random.nextInt if you want a value between 0 and 1? 1. Is it 1?
So when you say pass in, that's
2, right? Because remember, the value you pass in is how many values you want. So if you pass in a 2, it's going to be 0 or 1.
when you say pass a value, that's whenever you put random value or in parentheses, you put the number 2.
Right, so here's your random object. Dang it. Oh, I'm hitting this button and it's erasing.
Now when you say random object, it's an object name, and then random is the method that will pass that number?
Random is the name of the class. An instance of that class is what we call an object.
And then that's what we create, right? We create
Right, and then what you're going to pass in here is a 2. So it's very similar to what I did over here for the die, where,
Random,
wait, where was it? Oh, right here. Wait, right here. So this is me instantiating my random object. Once I had my random object instantiated, that's my random object, what's highlighted. I was able to invoke the method next int and pass in a 6. Passing in a 6 gave me a 0 through 5, but then I had to offset it because I wanted a 1 through 6. So I had to do a +1 to get 1 through 6. Yes.
For that one that you have highlighted right now, should you have used number of sides for constant instead of the
You're absolutely right. I just totally overlooked that. You're right. I mean, what's the point of having a constant if you're never going to use it? So Control C and Control V. Okay, I guess one thing I probably could have done is made like a min value and a max value. Like min value of die 1, max value die 6. But I'm not going to make you get all technical like that. In fact, I don't want you to worry about making the constant. I just want you to worry about making this work, right? I want you to try to get this done by midnight. Obviously, I'm not going to grade it at midnight. I probably just watch Netflix or something. But I will grade it by the weekend. So don't just blow it off, and like try to get it done at least by this weekend, because I will sit down and grade it on Sunday probably. Okay, so like I think I gave you enough to start that. I'm gonna go ahead and just type up the actual quiz. I know there's a class coming in at 8:10, so you don't have to stay here to work it, but I do want this in by the weekend. If you don't put it in by the weekend, I'm just gonna have to give you 0. But if you need help, I don't mind helping you. As soon as 8:10 comes, I'll move to a different classroom, and I can help you in a different classroom. Okay? I'm going to type up the quiz, and I'll put all the requirements in there. But I think for the most part, you know what to do, right? This example that I did with the die is on Dropbox. Okay? All right. So you guys are free to go, but get your quiz in before the end of the weekend. Preferably do it tonight while it's fresh in your head, right? That's always the best time. But if you like to not remember anything, then just wait till the weekend and blow it off and get a bad grade.